We started class today with you doing some estimating to the nearest euro. So all you need to do to estimate 20% of a service charge on a 49.99 euro bill is think of this as 50. 20% is twice 10%. So if I take 10% of 50, that's like a tenth of 50, which is 5. And if 5 is 10%, then you double 10% to get 20, so you double 5 and you get 10. Same thing with the next one. Think of this as 150. A tenth of 150 is 15. You just literally are dividing by 10 to take a tenth, and 15 doubled is 30. So a 20% service charge on a 149.99 euro bill is about $30. The same thing with a 249.99 bill. Think of that as 250. 10% is 25, so 20% is 50. So quick and easy way to do some mental math estimating. So the change today is literally going from equations to inequalities. So to get you thinking about that, if I say that x is 3, and I say how many solutions are there, there's only one, and the only one it can be is 3, because I told you x equals 3. But if I say x is less than 3, or x is less than or equal to 3, there are infinite solutions, because numbers go on forever. So x is less than 3 is any number infinitely that's smaller than 3. And x is less than or equal to 3 means including 3 and every number less than at 3. And remember that number lines go infinitely in both directions, so there are infinite solutions. So to graph x equals 3 on a number line, literally, you need to have a number line and a dot on the 3. No shading, no arrows, because there's one solution. To graph x is less than 3, you need an open circle on the 3 and shade everything to the left, because the x is somewhere over here. Okay, it's to the left of 3, and the reason we put the open circle on 3 is because it'd be impossible to pick a number that's less than 3. If I pick 2.99 and I tried to find that spot, well, what about 2.999 or 2.099 or we just wouldn't be able to include all the numbers. So we put an open circle on 3 and we shade to the left, and we shade the arrow to, because that shows that we can go infinitely to the left. And the only difference between the green and the purple is that now I need to include 3, because if I say all the solutions are less than or equal to 3, that means I now can include 3, so the solid circle includes the 3, and we shade to the left. So a little neater, that's what it looks like. Same thing. All right, and then I said, how would you graph the real-world solution to water freezing in Fahrenheit at below 32 degrees? So you've got to think what x represents. X is going to represent the degrees in Fahrenheit. So to write an inequality statement, all the degrees in Fahrenheit where water freezes are less than 32 degrees. So this is just a statement of inequality. And then to graph it, always put one number bigger than 32 and one number smaller than 32, and we need an open circle, because at 32 degrees the water's not frozen yet. As soon as it gets below 32 degrees, then the water's frozen. So that's the statement and the graph. And then some real-life situations require double inequalities. And as the word implies, double, these are statements that have two inequalities. And always be sure to use the same inequality. They're either going to be less than and less than, or greater than and greater than. Now the greater than or equal to doesn't really matter, but you can't mix less than and greater than in the same double inequality. So if the elevations in the United States range anywhere from being in Death Valley at 86 meters below sea level to up in the top of Mount McKinley at 6,194 meters above sea level, we can represent that with a double inequality. So think of a number line, and the way that these numbers are arranged on the number line, with my smallest being to the left, and then x is all the numbers in between, and my highest mountain peak, 6,194, being to the right. So this is the inequality. I'm including Death Valley, and because it's below sea level, it must be negative. And I'm including the top of Mount McKinley, because that is one of the elevations possible in the United States. And when I graph them, I must have equal intervals, so I get a picture of the vastness of the differences between elevations. So it's okay to estimate where my negative 86 is, and it's okay to estimate where my 6,194 is, because the inequality statement itself tells you what that number is. But notice we counted by thousands here so that we have equal intervals, so that the number line actually gives us an accurate picture of the size of the differences. Okay, so when you multiply or divide by a negative number in an inequality, something strange happens. So I showed you a bunch of examples and had you look for the pattern. So to solve 2x is less than 8, we just divided both sides by 2, and x is less than 4, and we tested a number, so we pick a number like 3. 2 times 3 is 6. 6 is less than 8, so we knew it was right. Same thing here. Divided both sides by 2. We get x is less than negative 4. We pick a number that's smaller than negative 4, like negative 5. 2 times negative 5 is negative 10. Negative 10 is less than negative 8, so it checks. And so on. And these were all true, and they all worked. And then the circled ones, something strange had to happen. In order for this to remain true, we have to reverse the inequality sign. So this said less than, and the solution has to be greater than. This said greater than, and the solution has to be less than. And I asked you the question, why do we have to do that? Well, first of all, let me show you that's the only way it will work. We divide both sides by negative 2. And 8 divided by negative 2 is negative 4. So the only way this can be true is x has to be greater than or equal to negative 4. So let's pick a number bigger than negative 4, like negative 3. Negative 2 times negative 3 is a positive 6, and 6 is less than 8. So if I didn't reverse the inequality, that wouldn't have been true. It would have said 6 is greater. Right here, if I would have picked a number that is bigger than, smaller than negative 4, if I didn't reverse it, and I put in negative 5, I would have something like 10 is less than 8, and that's not true. So you have to reverse the inequality sign. And none of you really knew why, so we did a little activity to help you see why. So if I just take some numbers that are increasing in order, on a number line, negative 10 is less than negative 5, and that's less than 0, and that's less than 5, and that's less than 15. So we can put that inequality sign in there. And if I multiplied each of these numbers by a positive 2, I'm just doubling them. So really, I'm just making the distances between them on the number line greater. But still, negative 20 is less than negative 10, and that's less than 0, and that's less than 10, and that's less than 30. So they do stay in the same order on a number line. And here's my number line, so you can just see they're in the same order. Just double the values. But if I multiply by a negative 2, look what ends up happening. Negative 10 multiplied by negative 2 is a positive 20. And negative 5 multiplied by a negative 2 is a positive 10. So when I multiply by a negative times this negative changes the sign to positive. And this was positive. When I multiply it by a negative 2, it becomes a negative 10. And my 15 becomes a negative 30. And notice where those numbers are on the number line. Because the positives become negative and the negatives become positive, they all switch places. So now when I take those answers, 20 is greater than 10, which is greater than 0, which is greater than negative 10, which is greater than negative 30. So that's why I have to reverse my inequality sign, because the numbers switch sides on 0 when a negative goes to positive or a positive becomes negative. So whenever you multiply or divide by a negative number, you have to remember to reverse that inequality sign. Sounds confusing, but it really isn't if you imagine that it's switching to the other side of 0 on a number line. So then you tried some. You solved these exactly like you solved equations, except for that one exception. So we divided both sides by a negative 7, reverse the inequality sign, and 126 divided by negative 7 is negative 18. So all the solutions are less than or equal to negative 18. We graphed it. We put a solid circle on negative 18 and shade to the left. And now when you check your solution, pick one of the numbers in the shaded region, negative 19, and I substitute it into the original inequality. So I'm going to multiply negative 7 times negative 19, and that must be greater than or equal to 126. And the product is 133, and it is greater than 126, so that we know that our solution is correct. So always when you check it, choose a number in the shaded area for your check. And then we tried this one, and there are no negatives here. So when you divide both sides by negative 4, you don't change the inequality. But we have kind of an awkward worded situation here. It says 5 is greater than or equal to x, and x is all the numbers of the answer. So it's better to read it right to left and flip it around We're not reversing the inequality. We're putting x on the left and the 5 on the right. So we're reading it this way. X is less than or equal to 5, and then writing it from left to right. So solid circle on 5, shade to the left. Check with 4. 4 times 4 is 16, and 20 is greater than or equal to 16. So we know that it's right. So we checked your homework, and then you have some practice to do tonight. And by Sunday night, 3 hours and 15 topics on ALEKS, unless you've finished your orange and green sections of your pie, and then you just need a total of 7 to 8 topics for this week. And remember, you do have a quiz on Monday on lessons 3, 4, and 3, 5. Not on inequalities, just on AX plus B equals C.